Welcome to our first lesson in the module of Geometry and Measures, which will explore degree measures. Today's lesson is all about understanding and operating with angles. We will start by understanding what angles are, aiming to develop a firm grasp on how they work as a mode of measurement within a shape. You'll also discover that a complete circle is made up of 360 degrees, and a straight line constitutes 180 degrees. Next, we'll learn how to use a protractor, a handy tool that makes measuring and drawing angles a breeze. Step by step, I will guide you on how to accurately measure an angle, draw one from scratch, and identify an angle in a given shape. Finally, we will learn the universally accepted conventions on how to label angles, which can further enhance your ability to discuss and solve geometrical problems. Now, you must be asking, why is it essential to have this understanding? Let's take an example. Imagine you're a town planner needing to design a series of roads. Many of these roads will intersect, and the intersection will create angles. Measuring these angles and designing them correctly will be critical for traffic flow and safety. Hence, understanding how angles work is not only a mathematical need but also an everyday necessity. With this established, let's get this session started. An angle is a measure of rotation or turn between two intersecting lines. The lines can be either straight or curved. The point where the two lines intersect is called the vertex, and the two lines are arms. Let's now look at some key angles we need to learn. A quarter turn is called a right angle and measures 90 degrees. A half turn is a straight angle and measures 180 degrees. And a full turn represents a circle and measures 360 degrees. To measure an angle, one can use a protractor, a semicircular tool marked with degrees from 0 to 180 on its edge. To measure an angle, you line up one arm of the angle along the baseline of the protractor and the vertex at the center point. The second arm will pass over the protractor, and the measurement where it crosses is the size of the angle in degrees. In this case, the angle is exactly 47 degrees, because this is where the second arm passes through the protractor. So what else can a protractor be useful for? Well, drawing angles also requires a protractor. You start by drawing a straight line that will become one arm of the angle. Position the protractor on this line and put a dot at the desired degree measurement. For example, if we want to draw an angle of 60 degrees, we draw a dot here. We then draw the second arm of the angle through this dot. You have now drawn an angle of 60 degrees. Angles are named and labeled by using 3 points. The angle shown here can be labeled angle BAC. The middle point is the vertex of the angle, and the other 2 points are on the arms of the angle. The name is always written with the vertex point in the middle. For example, in this angle labeled BAC, B and C are points on the arms, and A, which is in the middle, is the vertex. Angles can also be denoted with a small Greek letter theta or alternatively alpha placed at the vertex. Let's now apply this knowledge to some problems, beginning with the basics by measuring an angle. Imagine we have the two intersecting lines shown here, and we want to measure the angle created by these two intersecting lines. We take our protractor and line up the center with the vertex of the two lines, and also line up the baseline with one of the arms. Now we look at where the second arm passes through the protractor. We read off the protractor to measure this angle. In our case, we have 120 degrees. So the angle created by the two intersecting lines is 120 degrees. Now that we know how to measure an angle, let's try drawing one, say, of 80 degrees. Start by sketching a straight line, which will act as an arm of the angle. Next, position the protractor so its center point is on your line, aligning it with the baseline of the protractor. Spot the 80-degree mark on the protractor scale and mark a small dot at that position. Remove your protractor carefully and draw the second arm of the angle from your line to the dot you marked. Congratulations, you've just drawn an 80-degree angle. Now, for some practice, pause the video here and use your protractor to draw the following angles: 65 degrees, 170 degrees, and 52 degrees. The answers are on the next slide, so make sure you've answered all 3 questions before carrying on with the video. Okay, so hopefully you've had some time to complete those 3 practice questions. Here are the answers. First, a 65-degree angle should look like this. A 170-degree angle should look like this. And finally, a 52-degree angle should look like this. Lastly, we will look at an example of labeling angles. We label an angle using 3 points. The middle point is always the vertex of the angle and is named after it, while the other 2 points are on the arms of the angle and define its size. Taking an example, if the vertex of the angle is called point A, and the other 2 points on the arms are points X and Z, we will then call the angle XAZ, noting that the name always starts from one arm, goes through the vertex and ends on the other arm. Now, for some practice, pause the video here and correctly label the following angles. The answers are on the next slide, so make sure you've answered both questions before carrying on with the video. Here are the answers. The first is angle POQ. The second is angle BAC. Well done if you got these correct. Keep practicing! We have now reached the end of the lesson. To summarize, in today's lesson we explored angles as a mode of measurement, vital in assessing and representing rotation or turn. We defined an angle as the space between 2 intersecting lines or arms, with the intersection point called the vertex. We identified the different types of angles based on their degree measurement, including right angles, straight angles, and full rotations. Then we delved into the practical aspects of measuring and drawing angles, emphasizing the use of a protractor, with careful placement at the vertex as a crucial step. Lastly, we discussed naming and labeling of angles by using 3 points, always placing the vertex point in the middle. With this foundational understanding of angles, you're well equipped to apply these concepts in a myriad of scenarios in mathematics and beyond, in areas such as engineering, architecture, and spatial design.